There are two important types of motion constraints in Inventor: rotation and rotation translation. Rotation is similar to a belt or gear drive, and rotation translation is similar to a rack and pinion. We'll discuss the rotation constraint in this lesson and the rotation translation constraint in the next one. The rotation constraint is used to replicate the motion of connected gears, pulleys, or any components that have related rotational motion. It's important you understand that there isn't any physical interaction between the components in the assembly. You enter a ratio for the relative rotation when you create the constraint, but it doesn't automatically update if the diameters of the components change. Again, there is no physical interaction. This simply allows you to try and emulate the motion of the mechanism. In this lesson, we'll take a look at how to apply the rotation constraint to a pair of pulleys as well as a pair of gears. At this point, the two pulleys are free to rotate independently of each other. To simulate a connection between them, I'll start Constraint and click on the Motion tab. The rotation type is selected by default. The rotation constraint is defined by selecting two axes of rotation and specifying the ratio between them. Selecting an axis of rotation can be accomplished several ways. You can select an axis, a work axis, a conical or cylindrical face, an arc, such as the circular edge of this pulley, or a linear edge. In this case, I'll use cylindrical face on the rim of each pulley. By selecting the faces, Inventor can calculate the ratio. Keep in mind, this is not a parametric relationship. If you change the diameter of one or both pulleys, you'll have to update the ratio. Before clicking OK, notice the two solutions are forward and reverse. Forward causes the components to rotate in the same direction, like pulleys, and reverse causes the components to rotate in opposite directions, like gears. The default setting is forward, so I won't change it. I'll click OK and the rotation mate is added. I'll quickly check to make sure the constraint is correct. When I turn the handle on the green pulley, the blue pulley rotates more quickly. In the next example, let's take a look at creating a rotation constraint between two gears. The process is not much different than the previous example. I'll select the z-axes of the gears and select the reverse solution. Once the axes are selected, I'll define the gear ratio. This time, I'll enter the number of teeth on each pulley, 29, 16. I'll click OK and the gear mate is complete. I'll rotate the gears to make sure the direction of rotation is correct. If you have to change the gear ratio, just click on the constraint in the browser. The Edit field shows you entered 2916, so you can just update the number of teeth. Keep in mind, this is only a simulation. The gear teeth are not actually interacting and may in fact be overlapping.